Hello, hi, this is Thacienne. How are you? How have you been? Good morning if it's morning, good afternoon if it's afternoon, and good evening if it's evening. In today's presentation, I'm going to show you how we can make side-by-side plots in Rstudio. In some cases, we may need to visualize data with different plots, but we need those plots to be in just one figure. And how can we do it? That's what I'm going to show you today. I will also show you how we can add some graphics, some elements on an existing plot. You already have a plot and you want to add more elements on that plot, how we can do it. I hope you are going to enjoy today's video. If you like this video, don't forget to click like. And if you have anything to add on the presentation or anything to ask, write it down in the comments so that I will check it. And if it's your first time to be on this channel, please don't forget to subscribe and turn on the notification bell so that you will get notified anytime we upload a video. So enjoy today's presentation. Watch from start to the end. Let's start. Yes, so let's start by seeing how we can make side-by-side plots. We are going to use the same dataset that we used in our previous video, and that dataset was the iris dataset. This is a built-in dataset in R, and for those who are here for the first time, we can just have a quick overview of this iris dataset. Iris, yes. It is a dataset formed by 5 variables and 150 observations. The first variable being the sepal length, and the other one is the sepal width, and the other one is the petal width length, and the other one is the petal width, and the other one is the spaces. The spaces variable is formed by 3 spaces. As you can see here, we have 3 levels, then 3 spaces. Let me see those spaces. You can use the levels function to see which spaces you have there. Levels for iris spaces. For iris spaces, we have 3 levels, and the setosa, the versicolor, and the virginica. So you may need to visualize this data, the sepal length, the sepal width, the petal length, and the petal width in one plot. But let's first visualize, for instance, the petal length and the petal width in one plot, and we want to arrange them so that the first side of that plot we will have the box plot for the petal length, and the other range we will have the box plot for the petal width. So how can we do it? To do this kind of a plot, we use this function par. The par function takes 2 arguments. And the first argument, it is a vector which shows the margins that we want to use for our plot. It takes a vector, it's the mar, the argument is mar, and this takes a vector of 4 elements. The first element, the margin at the bottom, the other one margin for the left, and the other one the margin at the top, and the other one the margin at the right side. So let's say, for instance, that we need 4 lines of margin at the bottom, 4 lines of margin at the left, 4 lines at the top, and for instance 1.1 at the right side. This is the margin of our plots, and we need to define another argument. That argument is the mf row equal. So this argument also takes it's kind of a vector that has 2 elements. It has 2 elements, and the first element defines how many rows we need in our plot and how many columns we need. So in this case, we need 1 row and 2 columns because we need to place the box plot of the petal length in one column and the petal width in the other column. Yes, we need to have that this kind. So you define these elements, you define these vector, these numbers, depending on how many plots you have and how you want to arrange them. If you want one row, then the first element is 1. If you want two rows, then the first element will be 2. If you want 3 rows, then the first element will be 3, and so on, depending on how you want to arrange your plots. Then let's click enter. Now we have defined how our graphs will look like. Now we can start adding the graphs. So we want first graph to be the box plot. The box plot, and which box plot? The box plot for iris petal length, yes, and by spaces, by iris spaces. And on this graph we can add arguments, graphics, as we have seen in our previous video. For instance, we can differentiate these spaces by adding colors. That is defined by the argument color equal. And you define the colors that you want to use for each and every space. Let's say we want the stosa to be red, as in our previous video, and the versicolor to be blue, to have a blue color, like it where blue, it's blue like this. And we want the veriginic to be green, then you write green here. That's the colors. Our spaces, we have 3 different colors: red, blue, and green. You can also add the main title to your plot. Then this is defined by the graphic main. Then main equal. You define your title. Then in this case you may say that it's petal width, this petal length by spaces. And you can, for instance, give a title to your x coordinates and a title to your y coordinates. To do that, we use xlab. Then xlab equal, in this case it will be spaces, and then ylab equals, then in this case it's the petal length. Yes, if I click enter, something is wrong. Box plot is not known. Please write it when it's box plot, not box plot. Box plot here. Box plot. Yes. Box plot. Yeah. Then if I click enter, you get our plot here. So if you can see it here, we have already our plot, and we have an empty space on the second side. Why is it empty? It is empty because we have defined that we need 2 plots on our figure. So it is expecting to get another plot. So let's add another plot to this figure. Then let's add the box plot for the length, petal length. Let me copy this and paste this here. Then we can change the length to width. This to be width. Petal width, and then you can change the title to be the petal width. Petal width, and you can change the y-axis to be now the petal width, like this. Then if I click enter, here you go, we get the second plot already here. And if I zoom it, guys, and that's too large, I make it like this. So you see, we have two plots in just one figure. So isn't it easy and useful and beautiful, of course? Yeah. So you may need to make let's say a figure that has four plots. So it's just changing. You need to change just here. Let me go back here. You need to change. Let me clean this so that you can see it very well. I clean this. Then what you need to change here is just changing the numbers here. Let's say if I say that I want 4 figures. Then in this case, 2 at the first line and 2 at the second. It's not right, and the second row. And let me clean this graph so that you not get confused, guys. And I just wanting something long. Let me type it well again here. Yes, now I have it. So let's add. Now we need 4 figures. Let's add the 2 figures that we already have, and then margin too large. Okay, I make it big like this, and then again yes, now I have it there, and then I can add the second plot that we already had. It's this one. I add it there. Okay, now we have the box plots for the petal length and the petal width. So let's add to the second row the sepal length and the sepal width. So then in this case, instead of having the petal here, let me use sepal. Yeah, sepal. Yes, sepal width. If I let me type it where sepal length. Yes, then I change everywhere that I have petal, I put sepal. Yes, here. Yes, and Control Alt M. Yeah, no, this doesn't work. Then the petal sepal. This is the sepal. Yes, sepal width, and here also the sepal width. I add the fed graph. If I click enter here, I get my fed graph here for the sepal length. Let's also add the sepal width on this graph. Then I change length to width here. Width, yes, and yes. Then if I click enter, I get my 4th graph in just one figure. Let's zoom it and you see how it looks like. It looks just like this. So you see, very nice and beautiful. Yeah, so that's how we can create side-by-side plots. Just use the function par, define the margins, and define how many figures you want to put in that figure, that main figure, and you add your figures as you want. Yes, so let's move on to another topic. So yes, guys, now let's see how we can add graphics to an existing graph. Let's see first how we can create an empty graph. To create an empty graph, you can use, for instance, the function plot. Yes, plot, and you specify that you don't have anything by using null argument. This says that it's empty, and you define the starting point and the ending point for both axes. Then for x-axis, the x-limb, we want to start from 0 to 100. And then for y, it's y-limb, and we want to start from, for instance, from -1 to 1. This will give us an empty plot like this. You see, we have a plot, but it's empty. It doesn't show anything except the coordinates. From 0 to 100 for x coordinates, and from -1 to 1 to for y coordinates. So we may need to add some graphics to this empty plot. And let's say that we want to add some cosinus, so cosinus values of a given vector. And let's say we have x, we define x in this way. Do you remember how to use the function sapply? Sapply, double P, sapply, of course, double P. We want to compute the cosine of some numbers between 1 and 100. Yes, and then the function x, and we need to compute the sine of our values x over 10, and also the cosine, then cosine of our values x over 10. This, yes, we have our x. This x, it's a vector. Let's see how much dimension it has. X, it has two rows and 100 columns. One row for the cosine of x over 10, and the second row for the cosines of x over 10. So I want to add these two functions on this empty plot. To do that, you can use, for instance, the function liness. Then liness, what do we want to add? I want to add this x, the first row, the cosine of x over 10, then the first row or the columns, and I can specify the type of graph I want to have. Then type, I want a lining graph. You can also specify, for instance, the color. Then say the color, I want a red graph. Maybe I like red. Red is my favorite color anyway. So I want it to be red. So if I click enter here, so you see, my function is already here. The plot was first empty, then I'm adding a graph. So let's add also the cosine on this graph. So now we have to liness again. What do we add? Now we will add the second row, and all the columns, and the type, of course, the same type. Let me use also a line type equal air. And which color? What is your favorite color? Now let me say that I want it to be green. We need a green environment. So yes, yeah, so you see our graph also is there. This is the cosine and the red one for the sine. So you see, you may, for instance, want to show these surfaces between the cosine and the sine by using the segments to connect these two functions. And how can you do it? For instance, we can use, for instance, the function segment. Is it segment? Yes, segments. And what do you want to segment? You need to define your values. It's from 1 to 100, and then you need to define the starting points of your y values. Then y0 will be equal to, in this case it will be, let's say, this red, the starting points will be the red, and the ending point will be the green ones. So the red was for the sine, then it will be then x1. the first row in our matrix X, and then you have to define also the y0, then y0, the ending point of our segment, the y0 to be equal to now the cosine. Then the cosine is defined in our matrix as the second row, then to like this. Yeah, so that's it. If I click enter here, oh, something is wrong. Format argument y0 matched by, oh yes, something's there, something wrong here. This is not y0, this should be y1. Yeah, because I have y0 here and then y1, the ending point for the y-axis, like this. So you see, now we have our surface already clean, and you can see it very well. You can keep adding different values, and let's say that I want to add a horizontal line at y equal to 0. How can you do it? We can use, for instance, the function upline, and underline h equals 0. Then, so you see, you can add different things. If I upline, for instance, v equals let's say 40, I will get a vertical line at 40. So you see, you can keep adding things as you want them to be on your graph. So you see, guys. So I think with this and the previous video, you will be able to make your own graphs in Rstudio. I hope you have enjoyed these presentations. If you have any question, please write it in the comment. Or if you have anything to add, write it also in the comment section. I'm happy that you have been watched this video, and I hope to see you next time. Don't forget to like if you like the video, and to share the video to your network. Bye. See you again.